All right. So good evening, everybody. My name is Yelena. I'm one of the graduate teaching assistants in the data analytics program. And the purpose of tonight's meeting is to help you get started with R and the R Studio. And this meeting is recorded, right? So here is the agenda. We're gonna talk about what R is, what is R Studio. We talk about the R Studio interface. Then I'll show you how to make sure that all your work is reproducible, right? Then we'll talk about looking at the data. For instance, what are the properties, what are the variables, etc. We do the data visualization, and there is some bonus at the end, but you have to stay through the end or watch this recording through the end. And of course, questions and answers. For the purpose of today's demonstration, we're gonna use the HR data set. So basically, this data set tracks employees or former employees, current employee or former employee, job satisfaction level, when the number of years after the last performance evaluation, number of projects that the person was on, the average monthly hours, and etc. Right? And then there is a variable that tracks if an employee is still employed or if an employee left the company, and the salary level, right? So that's an employee information. And this is the source of the data that we'll be using tonight, right? Now, but first, what are we talking about? What is R and what are its advantages? Well, R is a programming language that we use for statistical analysis mostly. It's free and it works really well in academic environment. It's also available for the different operating system. Like if you're a Windows user or if you have Mac, right? There is the version for you to install. There are excellent data visualizations capability. Then you may save all your comments in a script and make sure that your results are reproducible, right? You may share your results and as well as the code with others. There is an excellent documentation. And then you can also, this is going to be in couple semesters, you're going to see that you can use R with databases. Then there is more than one way to produce the same result, and also R supports parallel processing. Well, of course, there are some drawbacks. Well, of course, if you look at R itself, there is no user interface. You have to write all the code, right? So, and you need to put some effort to practice and learn. You have to learn you really need to learn how to read the help pages. That's going to be your best friend here. Now, remember, R is case sensitive, right? So if I put Yelena in all uppercase and Yelena is all lowercase, it's different person, right? Let's say this way. R may not solve every single data mining problem and data analytics problem they're trying to solve, right? And then keep in mind the performance is a little bit slower than Python and Java, right? Then this is very important. When you need to install R on R Studio, you need to have the admin rights for the PC where you're trying to install. Or if you're prompted to enter admin username and password, you better know what that username and password is, all right? So you have to have admin rights to be able to install it. And you might be wondering, hey, Elena, what do we need to install? So you have to install two things. Number one is the R itself, right? And then there is a different web page for Windows and for Mac. The current latest version is 3.62, but in about 1 week-ish, they're going to be 3.63. They're going to be new version shortly, but right now it's 3.62. Then you have to install the R Studio. Basically, R Studio is the interface that runs on top of R, right? So there are some Windows menus, there are some menus, right? So a little bit less code to write, but still, you need to make sure that your work is reproducible. You don't want to depend on window menus, right? You want to know how to just run the script and to be able to get back to where you stopped at the last session, right? So what I'm gonna do is I'm gonna launch the R Studio, right? So here I'm gonna be doing in R Studio, right, the hands-on part, but I'll be referring to slides as well. But just remember that RStudio, it's an IDE, integrated development environment. It may simplify your process of learning learning R, right? And it also allows you to preview the variables, different variables and functions, right? So basically, when you launch it for the first time, you're gonna see 3 windows, right? You're gonna see 3 windows. This window, this guy here, this is called the console window. So you may type your commands in here. All your output will show here. All your warnings and error messages will also show here. So one thing to remember is that if you see a message here, it may or may not be an error. Some messages in R are informative, right? So it may or may not be an error, but this is a console window, all right? So here at the top, it tells me what R version am I using right now. I'm on 3.6.2, but in a couple of weeks, I'm gonna be upgrading as well. Okay, so here, this window on top, it shows me my current environment. Environment means anything that I have in memory at the moment. I just started my session. I have not done anything yet, so this is empty. Here, this is history. It's going to show you the history of your commands. Well, before this meeting, before the session, I was running some of the updates. I was updating something. So here are the commands that I ran, right? And you can also use this broom here. You can clear the history, right? So I just cleared it. I cleared my history. Okay, so history is basically the history of commands that you recently ran. Now here, files, here it will show you which files you have in the current working directory, and I'll talk to you about the working directory as well. So that's the default location on your hard drive. If I was trying to save the file, right, or open the file, that's the location where R is going to look at first. Plots. Right now, it does not make sense because I did not build any plots. I did not do any visualizations yet. Packages. Basically, the R code, it's organized into the pre-built R code is organized into the library, so to speak, right? So package, it's a collection of functions. It can have help pages. It can have also the data sets as well, right? Some packages come pre-built, like anything that you see in a system library, these guys here get pre-installed. When you installed R, system library is pre-installed for you. And one of the packages called dataset, so that's where the iris package is. The iris package that you're going to be using for the first homework assignment, iris dataset is in this package, datasets, right? This is one of the pre-installed packages. Then there are also user packages. Those are the packages that you install. And for your next assignment, you'll have to install the rules package. That's going to be the package that you will use for week 2 and 3. Okay, and I'll show you more details when we get there. So this guy here is going to be your best friend because this is, you can see the help pages for different commands, and I'll show you how to do that as well. All right, and you can navigate the help pages that you opened in the past, right? So now what we're gonna do is we're gonna start working on writing the code, right? So in general, if you want to make sure, if you want to make all your work reproducible, this is what you're gonna do to start the new script. You're gonna do here, you're gonna go new file, and you're gonna select R script, right? So this is what you're gonna do for every homework assignment. You're gonna start new R script, and then you're gonna be typing your commands, right? Just for example, I type version commands, it's gonna return the current R version. All right, and then when I'm ready, when I want to save it, I click on save, and by default, it's gonna open my current working directory, and that's where it will want to save the file for me, right? So when I save the file, it will be saved with extension .r, right? Like Microsoft Word, for instance, extension .doc, right? PowerPoint has its own extension, and this is a R. Our file will have .r extension. So let's close this. I don't want to save it. But what I want to do instead is that for you, I created the code, right? Because I don't want to be typing the code while I'm doing the demo, right? So what I did for you is I already wrote the script. to open existing script, you can do this. You can do file, open file, and then you can locate on your hard drive where you saved the file. Alternatively, if it was the recent files that you have recently opened, you can do recent file. See this? Recent file over here, it's going to show you which files you had recently opened. So this is a shortcut, okay? So you can navigate, right? You can do open file and browse to the file location on a hard drive, or you can just do recent file if it's one of the files that you recently opened. So notice here, this is my script that I wrote, right? Because I want the work to be reproducible. Over here, this is a comment. Comment tells us what the command does. It's a non-executable piece of code. It tells me what it does. Now, the reason is you're documenting the code, right? So now I have written this code. I have a document that will help you as well, because you can review and you're going to have a copy of this code after this session, right? And it will help you review it, right, to see what I did. Okay, now let's run the first command. And your assignment, you asked to check what R version you currently installed. I realize I'm aware that it shows here, right? But as your window gets filled up with output, sometimes you want to know how to check it programmatically, right? Don't assume that you always have this information. To check the R version programmatically, you can do this r.version or version. There are two ways to do it. So if you do it r.version, or if you do it version, you get it correct. See, these two are correct both ways. And I wanted to show you in here, I'm showing you multiple ways to do the same thing, because in case if you, well, in R, there is more than one way to do things. I'm showing you multiple ways because if you have to, if it's written differently, if it's done differently in a textbook, right? Like if one textbook does R.version, another textbook .version, I want to, I want to make sure that you're aware that it's the same thing, okay? Now, and how did I run the command? I did this. I put my cursor on the command and I clicked on run, right? And I'm running right now. I wanted to run one command at a time. Ultimately, I could run the whole script, but I wanted to show you the output. I wanted to go over command at a time. And what I did now, I ran the session info, and it will give me the current R version, and it's going to tell me the operating system. This is more information about my computer, right? My PC. And see this attached based packages. So the packages, do you remember that we looked at this? And there are some libraries that come pre-installed when you install R. And these guys here are loaded in memory, right? These packages are available when you launch the session. They're loaded in memory. See this? And you see the check mark next to them. Like if I was going to use a function in a cluster package, I would not be able to right now because it's not available. Package is not in memory. Here it shows you what's in memory at the moment. And I'll show you later how to load it to memory. But this is just the command. It gives you the session information. This should give you the current time. ls is going to list anything that you have in memory. At the moment, you don't have anything because there are no objects in the environment. And alternatively, you can also do objects. Those two is going to return the same, right, same result. Data is going to list all of the pre-installed data sets that are in memory. And notice here is the output, and you're going to see your iris data set that you're using for the homework assignment. It's in a pre-installed package called data sets. That's where it comes from. Okay, so you could use R as a calculator. For instance, 5 plus 9. Well, this may sound easy, but wait a minute. Those things can be used inside other commands, right? So here, what this will do is it will output welcome to data mining to the screen, right? Now notice that, do you see this number 1 in brackets? Well, everything in R is a vector, even a simple output like this. This is a vector. Here we have a vector of one element, and the first element on this line is at position number 1. Remember, in R, you count the elements from 1, right? The first element of a list is at position 1. In some languages, it's 0, but in R, it's 1. Remember that. All right? So here, what we're going to do here, this is an assignment operator. We're going to create variable x, and we're going to assign 3 to it, right? So see this? Less than and minus sign, this is assignment operator. So right now, I'm going to create variable x, and I'm going to assign 3. And see this? Immediately in the environment, I have my variable x. So if I was going to go back and run my ls command right now, it's going to show me that I have something now in memory, right? So then if I want to output the value of x, I can do print an x in parentheses, right? I can do that, or I can just type x. That's a shortcut. Again, notice that I have this 1 in brackets. It means that this is a vector, and number 3 is the first element of this vector. Now here, this is a shortcut. I can have 2 operations, right, on a single line. What I'm doing in here is that I'm creating variable y, assigning 5 to it, and then printing the output. See this? So this is 2 operations in one, right? So if you want to assign 5 to y and print at the same time, you can do this. Okay, so now, suppose that I'm done with x. Well, in this case, it's just a number. But in general, if it was, let's say, huge, something huge, right? Whenever you don't need the variable anymore, you can delete it from the memory. And to do that, you just run rm command, rm, and in the parentheses, we specify which variable you want to clear from memory. There we go, it's gone. Now here, you do this command to delete everything. Now remember this, ls, right? What ls does, it returns the list, what that you have in the memory. Rm takes the list as a parameter, right? As a parameter, it takes what to remove. So here, this is going to delete all from memory, this command. Now, you could also do this, ultimately. You can use this broom. It will clear the objects from the workspace. It's another way. Okay? Now, options is going to display the different settings you have. Like, for example, when the messages are long, how many lines you're going to see until the outputs gets cut off, etc. Okay, here are different settings. Let's say this is a warning. If the warning message is more than 1,000 characters long, you're going to see the first 1,000, etc. Right? Here, this one is the same thing as a clear this window, the console window. So this is the same as how you hold the Control L key simultaneously, or on Mac it's different. It's not a control key, it's something else, command key, right? Okay, so now here, this one, def off, is going to delete all the plots. If you had a bunch of plots in here, you run this, and it's going to delete. Right. Well, right now it's giving a little error because there is nothing. I don't have anything in here yet. Okay, now what this will do, history 5, it will show the last 5 commands that I run. Here we go. So here, this is history, right? The history shows me the commands that I ran in the past, right? Past commands. And what I could do, for instance, I could do this. And when I type this and when I say to console, I repeat this command in console, and I can enter and run it again, right? I can rerun it. And also from history, if I do to source, then the command would be added to my script, right? Just know that. Now we're gonna continue to the vector. A vector is a list of any elements, right? Function C stands for combine. So here, what I want to do is I want to create a list of elements from 1 through 5. And one way to do it is just put C, which is combine, and I'm going to list 1 through 5 in parentheses. So this is going to create this list. I'm not storing it in a variable anywhere, right? I'm not assigning it. So that's why I see the output here, but my environment is still empty because I'm not storing this, right? Right now, what I'm gonna do is I'm gonna create variable X, and I'm going to store list of 1 through 5. This here column, it's a shortcut. Instead of listing 1, 2, 3, 4, 5, I can do this. It will take numbers 1 through 5. This might sound simple, but you'll see where these pieces are used, right? So here it is. And then always I want to check my work, so I just do X, and it will output. This is X. Now, remember that each element of the list has its position. So if I don't want to see the whole list, for instance, I want to see the element in position number 3, so I'll just do this. X in the bracket specifies a position, so that's going to be number 3, the third position. Here, this is going to give me the data type of an X, right? And this is the integer, right? It's an integer. Another way to do this is a type of, right? Then str is going to give you the structure. In this case, it's an integer, and the numbers are 1 through 5, right? 5 elements. Here, I want to create 1 through 5, and then 8 and 10, right? So this is how you do it. C is a combine function. I'm combining. See this here, this is a shortcut. It's 1, 2, 3, 4, 5. And here I just take 8, 9, 10. And this is going to be list, and I'm storing it in a Y. And now I display Y. Now suppose that I want to display only subset of Y. Here I want to display elements 3 through 6. So I specify it like this in a bracket, right? And again, I can check the data type, and I can check, do the str. This is the structure, right? This shows the elements. Now what I could do is, now remember, this is a numeric, right? I can multiply it by 2. So if I multiply it by 2, it will multiply every single element of this by 2, right? So here is the sequences. For instance, I want to generate the numbers from 1 to 10. Well, it will make sense later on when you do perhaps loop, right? When you repeat something 10 times perhaps, right? Well, you'll see that's going to make sense later on. But here, this is how you generate the sequence. You use the sequence, and here I'm storing it. By default, it's going to start from 1, go up to 10, and the increment is 1 by default, right? So when I do this, it's going to be 1 through 10. Here, I'm going to start from 2. I can specify that I want to start from 2. And here, I could also specify that I want to start from 2, and I want to go up by 2, right? This is a by 2. Okay? Now, this is really important. This is how you get help pages. Suppose that I know my command, right? I know the command I'm looking for, but I don't know how to use my command. So the command is bar plot. To look for help, you can do this. You can type the word help, and in parentheses specify the command name, or you can just put a question mark followed by command name. So when I type this, it's going to open my help page, and it's going to give me my information about the bar plot function. So I can read here, and I can read which arguments it takes, right? And play around. Now here, if we scroll down, it's going to give me some examples on how it's used, right? And again, what it's using in examples is the data sets that come pre-installed. There are some data sets that are pre-installed, and that is what it's using here, right? Those are the examples. So you could run those and see what happens, right? And it also shows you which package is this on. In this case, this is in a pre-installed graphics package. This function is in a graphics package, right? So there are 2 ways to open the help pages, but suppose that I'm not sure how to spell bar plot. I know that it starts with bar, so this is a command, apropos. It will show me which functions contain the bar, right? Then here, I can run the help command for any of this, right? It helps me know what I'm looking for. Well, example command is just going to show the examples that you saw here, right? So I'll let you play with it. And this one is going to search the R web page, about the examples for the help on a bar plot function. So if I do this, it's gonna open up your browser, and here are some examples online. Here is online examples on how to use this function. So you might find this helpful for your assignments too, right? Our site search. Here, so now what we're gonna do for this assignment, for this first week assignment, you're gonna be using a pre-installed data set, right? Pre-built. But now we're gonna change a little bit. I'm gonna show you how to read the data set that is saved on your PC, right? So on my C drive, I have a folder which I call dataset, and it's case sensitive. The first letter is uppercase. I have that folder called datasets, right? And in that folder, I have a file, hr_data CSV. So that's the data that I showed you on a slide. I showed you the preview. We want to read the data, but first thing what we need to do is we need to set the working directory. Working directory is a folder on your hard drive where R will attempt to look at to open the file. To set the working directory, you're going to run the setw command. But at the moment, let's see this. Get working directory, it's going to show you where your current working directory is, right? See users, and this is your username. In this case, it's my childhood nickname, Leonard, and then the documents, okay? This is where it's now by default. But the problem is I have my data sets in a datasets folder. So I have to run this command here to make sure that I am looking for the file in this folder, right? And this one, it sets the working directory, right? If I run this, it's gonna set my working directory. To see what my current directory is, it's get W command. Alternatively, notice this. Do you see the title bar of this console window? This displays what your current working directory is, the title bar, right? Now, suppose that I don't remember what my file is called. I can do list.files. Well, that works well when the list of files is small. Like this is HR data, this is a file. So now I know it. That's another way to check if this file exists, right? File exists is going to return true if there is a file with this name. Remember that the names are case sensitive, okay? Next step is we need to read the data from the file into our object called DataFrame. So to do that, the file is in CSV format. You're going to run read.csv command. This is the name of the file. Header equals true. It means that when I read my file, I want the column names in R to be the same as the column headings in the CSV file. So see this is a CSV file. See this column A is a satisfaction. When I read the file, I want the first variable to be satisfaction. I'm specifying that the first row as a variable name. That's what it means. All right. And this one, the separator is a comma. It means that my file is a comma delimited. I believe comma is the default, but if you're not sure what the default is, it's always good to specify. Okay, let's go ahead and let's run this command. Okay, so now do you see this? Do you see this global environment? What it did was it added the HR. It's a data frame. So if I expand it, right? You see this. This is the number of observations and the number of variables. You see the variable names, their data types, right? And you can see that. So here's that. This is a numeric. And you also see the values of the first few rows. Now you also see that some variables are factor. Factor is the same as a categorical. And the level is a unique value. So for instance, the department name has 10 possible values, right? And what this number 8 means is that the first row has the 8th value on the list. See these levels here? This is a list of values that this variable may take. And this is the index. Or like here is another example, the salary. it has high, low, and medium. Number 2 means that the value in the first row is low because it has a second position here. See this? Well, this might be a little bit hard and strange to understand, and you may not always have this nice environmental window next to you. So let's work on doing this programmatically, right? Let's work on doing it programmatically. First of all, you can preview the data in a spreadsheet view. This is a view command. This is a spreadsheet view, right? Now this is similar to what I just showed you in here, right? This is similar. This is a spreadsheet view. Okay, so here are my column names, right? This was column A, B, C, etc. And here is the data, right? This is a tabular view. And of course, you can filter it here, you can do the sorting, but what you do here, it's not reproducible. So if I was interrupted, right, then I need to return to my work. There is no way to reproduce what I did. But everything that is here, you can just rerun the code. That's it, very easy, right? And also, when you run the command, perhaps when you delete something, a variable, and you want to undo it, there is no way to undo it. The only way to undo it is to rerun the code, right? So that's another reason your work must be reproducible. Now, I showed you how to preview data in a grid view, and then there is this command called head. This will display the first 6 rows. The first 6 rows of your data, it will show it in a console window. Notice that the output is wrapped. It's because it does not fit on a single line. So it's going to wrap it. But it's showing you the first 6 rows by default. If I don't specify the number of rows, it's going to do 6. When I specify that I want 10 rows, it's going to show 10. As long as there are at least 10 rows in the data. If there were 2 rows in the data, it would just show 2, right? Tail command works in a similar way, except it's going to show the command, the last 6, and this one is the last 10. Right, so tail is going to show the last 10 rows, last 6 rows, and last 10 rows, right? Because it specifies that I want 10. Here, so we just looked at the data itself. str command here is going to show the structure. Like what you were looking over here, this is a structure, but we need to make all work reproducible. We want to make sure that we know how to do it programmatically. You see this? This here, str command generates what you saw here, right? Another command is a class. Class is going to show the data type of the HR, which it is a data frame, right? It's a data frame. We read the data set in the data frame. And here, this will show if this is data frame, it's going to return true, right? Here, we have several ways to display the variable names programmatically, right? Now, see here, those are the variable names. But suppose that I have some type of code where I want to loop through my variables, right? So names, HR, is going to return what the variables are. Okay, notice here, this is in the brackets here, it says 1, right? Because this here is in position 1. This here is in position 4. Everything in R is a vector. So the list of variable names is a vector. This guy here, position 1, this guy here, position 4, position 7, and position 10. Remember, everything is a vector, right? So that's the reason you see this. You can use here names, and this one is column names. It's going to do the same thing. But I want to make sure you have 2 ways because you may see it done differently in a book, in different readings, right? DIM command, that stands for dimensions. It's going to show you number of rows and number of columns in the data. Rows, columns. But notice this itself, right, is a vector. It has 2 dimensions. The first dimension is number of rows. This one is a number of columns. But see this, if I want to see only the number of rows, I can run nrow command, or I can repeat this command and take only the first number from it. Right? If I take only the first number from this. So this is going to give me the number of rows. Number of variables you can do, there are several ways. First way is ncall. Then, of course, you can do length, right? Length is going to do this. Then I can take this command up here and take the second dimension. I could do that. Or see this names HR. Remember, names HR is going to return the list of what? Of variables. And I'm taking the length of the list of variables at the same thing, right? There's more than one way to do it. Just keep that in mind. Now here, this is another friend here, summary command. Well, the main difference here is that when you did the str command, it shows you the table, it shows you the data set, the data frame structure. Summary command is going to show you the descriptive statistics of each variable. So here it is. For numeric, you're going to see the 5-number summary, or it's a minimum, first quartile. Actually, it's a 6-number summary: minimum, first quartile, median, mean, third quartile, and maximum. So this is how you know that it's a numeric variable, right? So now here, this is a categorical variable. It's going to show you the values, and it's going to show the number of observations that have this value. For example, we have 4,140 people who worked in a sales department, right? What this means is that if you have more than 6 values, it will group the least dominant values into a category called other. So here it showed you the 6. It shows you the 6 most dominant, and then it grouped least dominant ones into the single category called others. Salary, it shows you the number of people who has its salary level. This one, it's a categorical variable, which is low. The values are high, medium, low. Now, look at this last evaluation. See this NA1? This means that you have one row where the value of last evaluation is unavailable, missing, blank, right? And here you also have one row where the average monthly hours is unavailable. It's blank. That's what it means. NA stands for missing value, and we'll get to it shortly. Okay, so let me see. I think I have a question. Yeah, question. Go ahead, type your questions, Alana. No problem. Go ahead and type your question. Type your question in the chat. I'll get to it. Okay, no problem. Let me. Okay, but while you type in the question, let me show you this. Okay, so this is a summary. Summary shows you all commands, all variables. But if I want to see just one, this is what I do. I type the name of my data frame, and I type the $, and I put the variable name. So what this will do, oops, Control Z, I undid the change. Okay, here it is. What this will do is it will show me the statistics only for one variable. This will show me only for the satisfaction level. See this? What I did was I typed this data frame name, $, and this is the variable name. Okay, so this is what I did here. Okay, yeah, go ahead, type your question. Let me see in the chat. Okay, for each department column, the other, okay, other, yes, basically what other is, it's for the department variable, what it did was here, it showed me the frequency counts. This one here, it showed me the frequency counts, how many people are in each department, right? Sales, technical support, IT, and so on. What it did was it picked 6 departments that have the most number of people. But then the rest of the departments were combined into other. And this is a total, this is a number of people who work in the other departments. Department other than sales, technical support, IT, product management, and marketing. So this is the rest of the population who work in the remaining departments that are not displayed here. It grouped them into other, right? It's doing a binning. Let me know if I answered the question. So this is not, it's within the variable itself. This variable is categoric variable, and the values are in which department the person is working. So the summary for categoric variables, it shows you yes. Okay, I'm glad I answered the question. Yeah, I want to make sure that it's clear because well, yeah, I want to make sure that what I explain is clear. Okay, so here, suppose I have 2,000 variables, right? And I'm interested in just one, so I can specify the variable name after the $sign, right? And then I will see statistic just for a single variable. Okay, now, so here, another way to show the statistics for all variables is this. There is lapply command. Lapply command will process the specify command for every single variable in the data set. So this one, I want to show the summary for all variables in my HR data set. So that's what this will do. I notice that it's showing me similar information, but it looks differently. And take a look at this department. What it did is showed each department separately. Instead of showing just 6 dominant departments and combining the rest into one, see this? It's showing you separately. So when you run the summary command like this, you use lapply, and in here you specify the dataset name, and here is the command. It's a different output, and you get to see all of the departments, right? So this is a difference. Instead of grouping the least dominant one into other, here you see all of them, right? Another thing is that if I want to see only the minimum, right? Like I want to see minimum satisfaction, I just do the minimum. Here I put the variable, put the dataset name, right? And I specify the variable name after the $sign. Then I can see this one is a range. It's going to show you the minimum and the maximum. That's what it's going to do. Now notice that the 6 number summary output didn't show you the standard deviation. However, you can run SD command to see that, right? Now here, if I want to see my unique department values, I can do unique, or I can also do levels. Right? So this is going to show me what my values are, right? What my departments are. Here, if I want to show the average satisfaction level per department, so basically I could show, or this one is maximum rather. This is the highest satisfaction level, but I want to show it within each department. So here I'm basically saying by department. That's what it's doing, and it's a 1. Okay, in this case, it's a 1. Now here, sometimes you want to set the subset of data. To take a subset of data, you specify the rows range. Well, in the bracket, you specify the rows that you want to take, followed by comma, and then the columns that you want to take. When the columns are omitted, it means that you want to take every single column in the specified rows. Like here I put HR. For the rows, I specified 1 through 5. I put a comma, and I did not specify my columns. So what this will do is it will display the first 5 rows, right? So in a homework assignment, when you're asked to show the first 5 rows, perhaps, right, you can use the head command and specify number of rows, or you can also do this, right? You can, here, this is the name of your data set. Here you specify which rows you want, and you want odd columns. So this is another way to do that. Both ways are correct, right? I could also create a new variable and assign the first 5 rows. So this is going to create variable new HR perhaps, and it's going to assign the first 5 rows, right? So you see this here, it created the new HR and I assigned it. So it added something in memory, right? Here, I want to take the first 5 rows and the first 3 variables. So that's going to take the variable at position 1, 2, and 3. That's what it will do, right? Remember earlier we discussed this column, right? It's a shortcut. It means 1, 2, 3, 4, and 5. And this is a column in the position, right? Another way to do it is this. See this, names HR. It's going to take the list of column names and 1 through 6, right? So I want to take the first 6. So let's run this one, right? So this will show the first 6. Well, if you see it done this way somewhere in the book, Just keep in mind, it's possible. Here, suppose that I want only columns at position 1 for 5. I can do this. Look at this. C is a list, right? So here I specify the list of column positions that I want to see. In this case, I'm taking the column in position 1, 4, and 5, right? Position 1, 4, and 5. Do you remember this? So what's expected? I expect to see satisfaction level, right? I expect to see average monthly hours and the time spent in the company. This is what I expect, right? So now let's run it. And I also expect to see the first 5 rows. There we go, right? That's what it returned. Also, I could specify the column name, but here I have to be careful because the column names are case sensitive, okay? So I want to take department and I want to take left, right? Those 2 columns, and I want to take the first 5 rows, right? So here I'm not gonna run this one because the output is huge, but when the rows are omitted, it's gonna take the all rows in the specified columns. When, see here, I didn't specify which rows, it's gonna take everything, okay? Here, this one, I'm gonna take one variable and take first 4 values. Yes, let me look at the questions. I love questions, by the way. What does the left determine? Oh, the left. Left is a column in the data set. It determines if an employee stayed in a company. This is an excellent question. So left value means it's 1. If the left value is 1, it means that the employee left the company, and left value is 0. It means the employee is still working for the company. You will see this data set used later on in the recordings, where your target is to predict if the employee is going to be retained, okay? So yeah, so this is a very good data set for, you're gonna see it, you're gonna revisit this data set later. So yes, this is a variable name, okay? And that's what I did here. Here, this is just the single column, salary. I want to display the first 4 values in the column, okay? So this is what it will do. It's the first 4 values. And the first 4 rows is low, medium, medium, low. Here I'm specifying the condition for the row. I want to show all variables, but for the rows, the condition is salary equals medium. Instead of specifying which rows I want, I specified the condition. I want the salary to be medium, and I want to select all columns. This is what it's doing here. Now notice this here. Well, it's because there is a limit on the number of characters that can fit into the output window. Earlier, I showed you the settings, right? So here, it only showed me the subset of data because the data set is huge. It does not fit on the screen, okay? So I can limit the return data further. I can specify, for example, department is HR, and salary is medium, right? So this is an AND operator. This will pick the rows that meet these 2 conditions, and it's going to be less rows. I have less rows omitted, but I picked here salary, medium, and department HR. I could specify another condition, etc. Right? Once in a while, you want to add a new variables. Like for example, in this data set, I have the time spent in the company is one of the variables in this data, and it's in years. Just for the example, suppose that I want to track months, right? I want to, for some calculation purposes, I want to have months. I'm gonna add a new variable called months spent. And to add a variable, I just do this. I just do HR $, and I put a new variable name. And this is an assignment operator. And I want to take time spent, and I want to multiply it by 12. So this is what it's going to do. Let's do this. This is your friend. This is going to show the first 6 rows, right? I like this command here. So what you see is the new variable should be added to this data set, right? And it's, oops, let's scroll down. And it's going to show you the month spent. This is what I just did. Time spent, this is in years, and I just added a new variable, and I just did multiply it by 12, right? Once in a while, you want to delete a variable. To delete a variable, you just set it to null. When I set this to null, it's gonna delete this variable. Right? You just set it to null, and then I run a head command to verify that it's gone. Now, you might be wondering why I'm gonna be deleting my variables. The reason is sometimes the variable stores personal identifiable information such as social security, name. You don't want to use it for analysis. That's one reason. Another reason is that it could be unique identifier, right? It affects the method performance. You don't want to be using unique identifier in your analysis. Another reason is most of the rows are missing data, right? Or, for example, it could be, let's imagine you have a state variable and the state is Maryland. All records are from Maryland, right? So I want to remove Maryland just to make sure that I'm using less memory, right? Something like that. So think about it. There are situations when you remove data, or sometimes it could be the skewness, right? Or, well, there are multiple reasons, right? But I just gave you some, okay? Now, here, this is a sorting. So why you want to be sorted? Perhaps I want to see perhaps people who have the 10 people with 10 higher satisfaction, right? Or perhaps if I wanted to see the top 10 scores on the test, is another example where you would want to sort the data. Sometimes when you sort the data, it helps you find the duplicates in the data also. So here, what am I doing is that I want to select all rows, and I want to order my rows by satisfaction level, and I want to see all columns. This is what it's doing. And it's gonna take HR sorted. This is gonna create new variable called HR sorted, and it's gonna assign everything, right? Sorted, all variables, and it's gonna sort ascending by HR satisfaction level, right? It's gonna do ascending, and then I can do head command to display the first 10 rows, right? In this case, well, the value is the same. I probably did not pick a very good example, right? But basically, this is how you do the sorting. You specify order, you use order, and you specify this here, how it's sorted. Like here, minus sign means that I want to sort in descending, right? So that means that the higher value will be first, right? So this is a descending. I can also sort it by two columns. Like for example, if two rows have the same satisfaction level, I want to also order it by the number of projects, right? So I'll let you guys play with it, but basically the idea here is that I can sort more than one columns. Like see here, this is the satisfaction level. And if the satisfaction level is the same, then I also wanted to look at the number of projects, something like that. So if I find two people with the same satisfaction level, I also wanted to look at the number of projects that people were on. Well, something like that. See this? This is a number of projects, and it's gonna sort ascending by default, right? So it's sorting ascending by satisfaction and the number of projects that the person was on within the satisfaction. Now here, this is what you can do with the, you have a numeric variable. Well, once in a while, the variable that was converted as numeric is not meant to be numeric. Like for example, variable left, it should be a factor because we know the number of values is known in advance. Here we know that left it's either an employee is either left the company or an employee is either in the company. For some reason it was read as integer, but it's not an integer, it should be a factor. So you use the factor function to convert it to the factor. So if I do this and I do the summary, you see that now it's correctly. I should not be seeing the average value for left. I should be seeing how many people left and how many people stay, right? Unfortunately, if you have a categorical variable with numeric values, R thinks that it's a number. No, in this case, left, it should be the categoric, because either left or state, right? There is no half state or half left, right? You either use a company or not. There is no such a thing as 0.5 or 0.6. We're not looking at your status like part-time or full-time, something like that, right? So, well, time spent with the company is a little different because there is no actually upper limit. That can be 5 years, 10 years, whatever, right? There is no explicit limit. Or I could also, like, for example, see this, well, in this case, salary is categorical, but some variables like evaluation, right? It could be 0.5, 0.55. There is no fixed set of values, and we don't know how many values are in between two values, right? So this is numeric, it's a continuous, right? But this one, in this case, should be a factor. This is how you convert numeric to a factor. And this is really a factor because we know that it's either left or not. And here, is factor is going to check this, right? So before, when it was showing statistics for the left, it did not make sense, right? Now it does. Here, this is a table command. It's a tabulation. I want to know how many people have a high salary, low salary, and minimum, right? And I can also do the frequency table for two variables. So here, it's going to show me the salary, and this is going to show me retention, right? If the person stayed or left, and this is a number of people. See this? So for instance, I have 82 people who had a high salary and they left the company, and then I have 1,155 people who had a high salary and they're still with the company, right? So that's basically what it's doing. It's a tabulation. So here is an interesting topic. This is a missing value. As you may remember that earlier I showed you that some variables don't have value specified, right? Last evaluation is one of them. So if I do this right now, is this. If I run the min command, if I want to see on average, how long ago did people have last evaluation, I want to do this and I'm going to run into a problem. So see that this variable tracks how long ago, how many months are since last employee evaluation. And I want to see the average, and I'm in trouble. Well, the reason is I have a row, at least one row, where the value is unspecified. Min function does not explicitly handle when you have missing data. What you could do is this. You can run NARM equals true. When you run this command with NARM equals true, it will ignore the missing values for the purpose of the average calculation, right? So this is a number of months or number of years since the last evaluation, the average. See this? This is a number of years, yes, since the last evaluation, something like that. So that worked, right? But sometimes we want to actually handle missing values. And how you handle missing values depends on your business problem. Sometimes you may want to remove the rows with missing values, but the problem is you're at risk of losing data, right? If it's just one value missing, sometimes you want to perhaps replace it with an average, right? Or perhaps I want, if the number of years since last evaluation is unknown, perhaps I want to set it to the average for everyone at the same salary level. I'm just giving you an example, right? Or I want to have, if it's a categorical variable, if it's missing, I want to code it as unknown. It's just an example, right? Or sometimes if I have a variable where I have half of the value missing, I want to remove it. Well, there are many ways, and the way you handle it, it depends on the data, depends on a situation, right? There is no prescription, so to speak. So here you will find these commands helpful for your next assignment. This one is going to check if you have any missing data, because remember, is an A command returns if the value is missing. Any is an A it's gonna return true if the data has at least one missing value. And then to see how many, you need to do the sum, because what this does is that it returns, this is an AHR, it's gonna return true for each value if it's missing, false for each value if it's not missing. See that the output is huge. If I run this command in this isolation, you see what it does? It's returning the set of false and true. False if the value is not missing, true if the value is missing. So sum is gonna count how many truths I've got, right? Here, in this case, I want to see how many last evaluations are missing, right? How many are missing? Here, I specified the variable name, right? I want to look at how many instances are missing last evaluation, right? And here, I want to see which observations are missing. So that's going to show me the index. This is the row number 375. So if I go here to my spreadsheet, and if I go down to 375, I'm expected to see something missing. Well, let's assume that the data is loaded in the same order as it here. And I'm gonna have to see, well, okay, well, the reason it shows 376 is because in the first row, I have the column headings. So this is a data row number 375, and this is column B, it's missing a value. And in this case, column B is the last evaluation. Oh, this is a last evaluation rating, actually. This is a rating, right? So this is a rating, and in that row, it's missing a value. Sometimes you want to see, okay? So here we know in which rows it's missing. Here, you want to show the observation where at least one value is missing. Basically, complete cases returns only the rows that have all values, and this is a negation, right? So this is gonna, I specify the condition on a row. I want to see a row if the case is incomplete, right? I want to see the row where I have at least one thing missing. So in this case, I see it. I've got my two rows, and in one of them, I'm missing the value for the last evaluation. And another one, I'm missing the average monthly hours, right? Now here, I can display how many values are missing in each column. This is what it's gonna do. This will show how many values are missing in each column. Because in your homework assignment, when you're asked to verify that the missing values were actually handled, you can use any of these commands in here to show, right, that there are no more missing values. You can use this, right? So now here, I'll show you what you could do. This is, you want to create the new data frame perhaps, and you want to omit the rows that have at least one missing value, and a.omit. This drops the rows that have at least one missing value, and it's going to assign the remaining rows to new HR data frame. This is what it's doing. This is another way to do it. Complete cases is another way to do it, okay? Now in here, this one, I want to set, if the last evaluation is missing, I'm setting it to an average. Now remember this will get me the average last evaluation. I have to specify an ARM equals true, because otherwise I won't be able to get my average, right? So this is the average last evaluation value. This is the average. I have to use this, right? This one is an assignment operator, but I want to assign it only if the value is missing. So this guy right here, this right here is going to select the values of last evaluation which are missing, right? And it's going to set this to this average, right? It's going to set this to this average. Now, also, I want to set, this is another way, I can set just predefined value. See this average monthly hours, this is my business rule. If the hours are not set, I want to set it to 200. I want default be 200. So this is another way to handle, right? So now if I run the summary command, it no longer shows that I have missing values, right? This is how you verify that it was handled. So now let me see the questions. I love questions. Just to clarify, NA omit HR, it removes, yes. NA omit, okay, what this will do is this. In memory, it will have the data frame with omitted rows. And A omit in general, and A omit is gonna generate the data frame that excludes the rows that have at least one missing value. Yes, but what we also doing is that we creating a new data frame called new HR, and we are assigning a subset of HR. We are assigning a subset, and we're taking only the rows that do not have missing values. Let me know if it makes sense. Please let me know if it makes sense, because this is an excellent question. I like students who ask questions, by the way. So, okay, so new HR, this will create the new data frame, and it will assign a subset of HR data frame, and it will strip off the rows that have at least one missing value, right? Yes, it's going to create a new copy of HR, and it will eliminate the rows with missing values. That's right. That's correct. That's excellent. But if I wanted to replace the HR itself, I would have to have an HR on the left-hand side. Yes. Yes, it will create a new copy, because if I look, let me look at this. Let me look at this here. This is what it did. New HR. It created new HR. And notice that it has the number of observation 14,1997, and in here it has 14,1999. So remember that I had two rows where at least one value was missing, right? Two rows. When I created new HR, I copied all rows from HR except for the two rows that had a value missing. I had two rows where at least one value was missing, right? So that's what it did here. Let me know if it oh, excellent. Yeah, I want to make sure that all questions are answered. Of course, you're gonna have more questions, but I want to make sure that, okay. Now here, this one is just gonna do again. See this? This is how you show that all missing values were handled. This command, it's gonna show how many values are missing in a column, right? So far so good, hopefully. What you're gonna do is a lot of, remember earlier discussion about the packages here? And I told you there are two types of packages. System library is what's installed when you install R. User library is going to be what you install, because not everything that you need to use is already pre-installed for you. You're going to do the discretization, you're going to do the association rules, week 2 and 3. Those packages are not pre-installed, you have to install it. But first of all, this is your little friend here. This is going to give you all available packages. This will open a web page, documentation web page, and it shows you the packages that are available. And something to keep in mind that a lot of packages get added almost every day. There are thousands of them. So, and some developers, not me, but some developers write their own packages, some advanced developers, okay? So it gets written all the time. So whenever you need to learn something, what you do is you look at the help commands. Help system is really useful. That's what I like. Now here, something important to keep in mind that here, these are pre-installed packages, but they're not available. I have to load the package in memory before I can use something in it. For your homework data set, you're using Iris. The datasets package, that's where Iris is. It's preloaded in memory. So you can just start using. You don't need to do anything special, right? Anyway, so library, it's going to show you the packages that you have installed, right? This is what I have installed. And when I run the search command, this is gonna show me what's in my memory. This is a list of packages that are available. This is what is right now in memory sitting, right? This one is gonna show me where in the world my packages are installed. So I have my packages in two places. When you install R, this is a folder where it's gonna be. Program files R, this is a version name and library. This is a system library. This is where these guys are sitting. Here, this is a location where your user library will be sitting. When you install the first package, very first package, it's going to create this folder. It's going to be, you see this is your drive here. It's going to be in a, there is a folder called users, right? So if I go to C, it's going to be the users folder. This is going to be your username. In my case, it's my childhood nicknames, right? So this is my name on the PC. And then I'm going to go in here. This is a documents folder. And this is going to be, it's going to add R folder. Then this is a window library. And this is 3.6. This is where it's going to store it. So here are the packages that you install. You're going to see a subfolder like this for every package that you install, right? Now this shows you the location where things get installed. To install package, you just write this, install packages, and here's a package name. I'm not going to run this command because I already have it installed, but the package that I installed, it's not available. I need to run the library command to load it in memory, right? Now, take a look at this. Take a look at this. See this message in red? This is not an error. This message is informative. What it tells me is this. I have another package called matrix, and there is something in my rules package that depends on the matrix. So basically, it says that it loaded a rules and matrix package in memory. This message is informative, right? It's not an error. Here, what also it's telling this that you have a base package, right, that may have the same functions. There are a couple functions that in a rules package with the same name as a base package. See this? These two functions in a rule package have the same name as a base package. So if you were going to use the right function from the base package, you would need to qualify the function name with a package name. That's what it means here. This message is informative again. This is not an error. The fact that it is red, it does not mean anything. If it's an error, it's going to say error. If it's a warning, you're going to see the word warning usually. Okay? So there are two ways to do it. Another one is a require. But the problem is if I ran require, I would not have gotten this message. Sometimes this message is important. I could be using two packages that have the same function name, right? Like for example, see the search, right? It's a function name. And if I had two packages with the same function, I would have to qualify the function name with a package name, right? So, yeah. Now here, this is how to see the help page for the whole package. I'm gonna type this library, and inside I put the help equals a rules. So this is going to show you the help page for the rules package. Rules is the first package that you're going to use. So that's the reason I picked it here. Okay, so then this package, it comes with VNet. So VNet basically is an examples file, so to speak. So you can type VNet command, and it's going to open examples that comes with that package. So for your next homework assignment, right, you want to read about the rules, it's here. And it opens up, this will open up this file is actually stored in your, it's pre-installed. It gets installed when you install the package. When you install the package, remember this, the documentation associated with that package also gets installed. Do you remember earlier I showed you the documents folder, right? I showed you the documents with the folder, right? Did we look at this here? See this? This is a rules. This is the package. And it also has the documentation. See this? There is a documentation that comes with it. and this rules here, it was installed. So some packages have a documentation that gets installed when you install it. In this case, it also has vignettes. Some packages don't do this, some packages do. Like this one, it does not have vignettes, but it does have the help pages. It's all stored, it gets installed when you install the package. So remember this for the next week, you're gonna use this, right? You're gonna use this package. Very often you want to check for package updates, right? So this command, it's gonna update all the packages. It's gonna install the most recent versions of all packages. You always want to install latest and greatest, and things get updated all the time. Now this command, detach will remove it from memory. So if I run this command right now, this will remove the rules package from memory. So now if I was going to use it, it will be unavailable, right? It's no longer in memory. And remove command will do the deletion. It will delete the package, right? So here is the favorite part, probably. A lot of people like visualizations. So visualizations, what can we do? In your homework assignment, you're asked to do the histogram, but do not limit yourself to the simple hist command. The hist command, yes, it will show the histogram. Like I want to see the histogram for average monthly hours. I just run it, here it is. Notice this is a plot stop. Here is my histogram. Okay, no problem, see this? Well, this is fine. I answered the homework question. However, what you want to do is, in another question, you're asked to look at the help page for the histogram, right? So what you could do is impress your teacher by reading what actually input parameters can the histogram take and use it. Like, for example, what I'm doing in here is that I want to change the number of beans, right? So I'm going to run this. I'm going to do this, right? Okay. How about if I try to change my border? I want to do the border blue. I want to change the color, right? So here, I want to use the blue color. I want to change the shading, and I want to label my x-axis, right? Etc. So here we go, right? But for your homework assignment, perhaps you want to put a title that has a meaning. Well, do something, right? You're not limited to just simple HIST command, right? Well, it answers the question. However, you're asked to read the help page for the good reason. So you want to throw some of this in there, right? Throw some of the parameters. And here, this is how I use multiple parameters, right? So I want the shading on the angle. And here I specify the density of shading, and etc. I label this x-axis, y-axis, right? And if I want, I can change the title. I'll leave it for you to play around. So basically, when do you use? You use the histogram for numeric variables, and the histogram is used to show the frequency, right? A table, basically, okay, remember the table command? We use the table command to create the frequency counts. The output from table command is used as an input for the bar plot command. I can store the output into another variable, right, and then do the plot. I can do that, or I can plug it in directly, right? Or I can plug it in directly. Do this, the bar plot, and then put this guy here inside, right? I can do that. Or I can store the output of this in a variable and put a variable. I can do that, both. Here, what I want to do is I want to sort it. I want to order the bars in ascending order, right? See this? So this will sort it, something like that. Here, I want to do the horizontal. I want to change the axis. See this? I can do this. Then I want to do the horizontal and also sort it. See? So don't limit yourself to the, basic command. You want to try it out. So for example, see this here, next command. This is a pie chart. This is good for categorical variables. Okay, but well, there are some problems. If you have a lot of values, it could be hard to read, but suppose that I do this, right? If I give you homework, and I ask you to do the pie chart, what you're gonna do is you can type the question mark and you can type pi, right? And then you're gonna do this. Then you're gonna look at the help command. You're gonna change. You can change the radius, for example, right? You can change how it's doing clockwise, etc. You can change the density of color. See this? You could change even the colors. You would probably want to go and play with some of the options. Don't limit yourself to just simply, answering the question. Now remember this box plot. This is also numeric variables, right? This is a box plot. Then there is also the generic plot function. So if you're looking at the single categorical variable, it's just gonna do the bar plot. If you do this salary, right? It's a categorical, but I want to type to make a line, right? You can specify type L, so this is a line. Here, if you have two categorical variables, this is what it's gonna do, right? This is for two categorical. Here, it's just a single numeric. It's not gonna look pretty, but that's what it's doing. It's not pretty, but I'm just showing you what it does. And this is two numeric variables. Well, just in general, just an example, right? So, did not Yelena say that there's going to be a little bonus at the end? Okay, does Yelena ever lie? Sometimes. Okay, but here what I did for you, I put, first of all, most of the stuff we talked at, I summarized it in here. Here, there is a web page called Cognitive Class. And a lot of coursework in there is free. So when you're done with this class, if you want to learn more, there are several courses that are free and you can take in there. And they're self-paced. And by the way, this one, if you do this one using R with databases, oh, that's interesting because there is one assignment in Data 650 where you actually use R to analyze data from the database. So just a little heads up. But see, there are a lot of tutorials online that you can look at to enhance your knowledge. Then there are a couple of groups on LinkedIn. I'm a member of both, so I recommend you join. And here just some useful documentation web pages that are helpful to bookmark. And we reached the question and answers time. So I like when people ask questions, and I like people who ask questions. So go ahead and ask me questions. Anybody. And if there are no questions, I'll start asking questions. Remember, lowercase x and uppercase x, are they the same? No, right? R is case sensitive. I want you to remember it, right? Let's go ahead. Let's look at the chart. Okay, yeah, excellent, excellent. R is case sensitive. That's right. So remember that. So sometimes you get an error where it says variable undefined. If it's a case, look how it's spelled, right? And look at the case, right? So, well, I went over a lot of stuff. After this, you're gonna get a link to recording and you're gonna get the slides and you're gonna get the code. But what I recommend, even if you were able to attend the session, I still recommend you to watch the recording because some concepts that I covered today need to be watched more than once. Believe me, some concepts that I covered today need to be watched more than once because it's a lot to absorb. Okay, is there a remove duplicate values command in R? Well, that's an excellent question. It's not an easy way. Not an easy way. Not that I know of, but we never know. We never know. There might be in some packages. So what I would have to do is I would have to run the search, right? I would have to do a little research because there are multiple packages that were written, right? Who knows? Maybe, maybe not. So I could just do this and I can type something like do. Let's see what it does. I mean, there is no built-in that I know of, but oops, for some unknown reason, it does not want to cooperate. Oh, here it is, sorry. I do top and I do search. See this? So now I can look through this, but more likely, see this, I don't have it, right? I don't have it installed. But then I can go in. Oh, see this, find duplicate values. See this? So I would have to click here, and then I would have to read through this, right? I would have to read through this and see if it's something that can be useful. See this? See this? There are a bunch of, I'm just using my help function. Okay. Oh, excellent. Yes. Okay. Okay. When, okay, let's see. What is the question? Okay. Yes. So what you would need to do is you would need to do a little, sometimes you need to do a little research. Okay. So now when making updates to data, if we fail to save, would it still update the data? For example, when updating the blank values. Oh, if you don't assign it to yourself, right? If you just run this command by itself, if you don't assign it, no, it won't save it. No, you need to do like over here. Let me go back where I'm doing the missing values. Right in here, I'm doing this missing values here, right? Okay. See this? If I did this here, if I just ran this here, right? If I ran this here, I would not make any update to the last evaluation. No. In order to update something, I need to have an assignment operator like this. Okay? In order to update, I need to have an assignment operator. Without the assignment operator, it's just gonna do this. It's just gonna display. If I don't have this, it will just do this. It will just show this value. See this? But in order to save it, to actually save it, I have to do assignment operator. I hope I answered this one. Okay? Yes. But then needs to remove duplicates, you would need to look. Oh, this is an example, unique. Oh, excellent. So see this? To remove this, do you see this? That's unique. See this? Unique command. This will remove duplicates value. See this? I found it. So this shows you guys that help is my best friend. Like Denise asked, hey, can you tell us how to remove duplicates? And from top of my head, I could not think of it, right? Oh, how? From the top of my head. But I did not get lost. Look at this, what I did. I put in here, I put dup, right, for duplicates, and it gave me a list of methods that I might be interested in, right? And then I found it, I found what I wanted, and I click on it, right? That's what I did. There we go. So that's a unique function, removes duplicates. So see this, I found the answer by using help. So how help is helpful, huh? So yeah, let's ask questions. Guys, I love questions. That's what we're here for. But yeah. And some of you might still have my email, right? You remember me from Data 610? I did the Cognos analytics or Watson analytics session, depending on when you took the class. Okay, so more questions? Questions, going once, going twice. Well, I hope you remember my name, huh? Okay, so yes, this less than and minus sign, this is used to assign a value to, yes, it's gonna assign the value to the variable or column. Yeah, but it saves to the source only if you use the source on the left-hand side, right? You have to use the source on the left-hand side. Like for example, if you add 5 to an x, to set it back, to actually update an x, you have to say this. You have to put something like this. You have to have an assignment operator, right? You have to have something like this. If I just do x plus 5, it's not going to save it. But if I do this x assigned x plus 5, then it's going to save it in x. This is what needs to be done, right? So you have to do this, right? You have to explicitly put an assignment operator. If I don't do this, it's just gonna display the value. It's just gonna output the value. to the screen. So if X is defined, aha, see this? It's giving me an error now. It says object X is not found. So I'll have to define it, okay? I'll have to go ahead and define it, but yeah, so I did not define my X. Oh, I did, but wait a minute, X is, see this, I did uppercase X, and it's a case sensitive, right? So I had to do this. If I do this, X plus 5, right? What it's gonna do now, it's just gonna display the vector with 5 added to each element. On the other hand, if I do this, X, I'm gonna set X to this, X plus 5, right? It's gonna add 5 to each element. See this? Now it's saved in X. Before that, it did not. Now it's gonna save because I'm doing assignment. Okay? Okay. Okay. Okay, and that update will appear, well, no. Well, no. Let me explain to you this. The data that you loaded from the CSV file will be stored in a data frame. It's going to be sitting in memory, okay? It will be sitting in memory, I mean that it's not gonna be, well, let's see, what's gonna happen is this. It's gonna be, when I loaded the data from the data file, it's going to be sitting in a data frame called HR. It's stored in the R memory. Any change that I made to that data frame is not going to be reflected in a file. The data in a file that you read is not going to be changed. The only thing that is changing is the actual data frame that's loaded in R. So if you made a mistake, if you deleted something that you should not have, what you do is you just run the script again. That's all. The work that you did, like over here, suppose that I made something stupid here, right? Like deleted something or whatever. What I could do is I could go back to the top and rerun the script, reproduce my work. Just maybe a few seconds, that's it. I don't need to redo all the code, right? Because my work has to be reproducible. That's another reason. So one reason is some homework cannot be done in one sitting, right? So you want to basically do a little bit, then when you return, you rerun the code to get back to where you stop, and then you continue. Another reason is that because there's no undo button, right? So if you deleted something by accident, you just have to undo the change by rerunning the code, right? So that's another reason. And another reason is that because the code reuse. What you do for assignment 2, part of data pre-processing, you want to reuse in assignment 3. So there's going to be some reuse. Okay, can you give us an example of the changing to another value? Yes, an example of changing the null to another value is in, let me see. Yeah, it's in here. I'll scroll down, let me scroll down. Okay, here it is. This is what I'm doing. I'm taking the average monthly hours, and whenever it's blank, I'm setting it to 200, right? This is what it's doing. It's gonna set see this here, it's gonna take, here in this case, it's gonna take the last evaluation, right? And whenever it's blank, it's gonna set to the mean. Yes, and in here, it's just gonna set to 200, okay? Yeah, I hope it makes sense. Okay, if I'm deleting my data with R, well, okay, first of all, if you deleted the data in R, it would be removed only from the R memory, okay? Well, but if you clean the data, there is if you do some data manipulation, perhaps you did the data cleaning, and it's a data frame, right? It's stored in the R memory, and then to get back to it, you would just need to rerun the R script. But of course, you can also write the data to the CSV file. You can write the data frame to the CSV file. And to do that, you just do this. You can type the question mark, and you can look up the write CSV command, right? There is a write CSV command, you look it up, right? You'll see the help page. you'll see the help page here, and it shows you how to do it. See this? You have a write CSV command, and this is how you would save the edited the file, okay? Okay, I hope it makes sense. Do you have to find the null values first in order to change the null values? Well, basically what I did in here is this will do it for me. I'm saying it here, see this? This is a variable, last evaluation, and in here, this is a condition. I'm taking each row where last evaluation is missing, because what this will do is NA, it's gonna look through every value in a column, and it will return true if it's missing. So this is dynamic. It's gonna find where the values are missing, and in here, it's going to replace it with the mean. It's gonna replace the missing value with the average, right? So that's what it's doing. The code is doing it for me, right? I'm not gonna go in and plug in the specific positions, right? But over here, I show you how to get the position. Here, which is NA, that's gonna give me the row number where the value is missing. This gives me the row number where the value is missing. I could go in and plug in the row number in here. I could do it, but the problem is, suppose that I have 1000. I don't want to do it 1000 times. I can do it dynamically like this. See this? What this is doing, it's checking is NA, right? Last evaluation. See this? It's gonna pick every row where last evaluation is missing, and it's gonna replace it with an average. Okay? That's what it's doing. It's doing it both at the same step, so to speak. I hope it makes sense. Well, some of it may need to be looked at more than once, because it's very difficult to absorb as much in one sitting. So you may need to, well, now you watched it, right? Now you attended the lecture. So maybe sometime when the recording is available, and that's what I'm gonna do tonight. I'm gonna send the recording and all the files to your instructors. Then they will post the recording, right? Once you get this, make sure to watch it again, okay? And I'm sure you'll have more follow-up questions, but some of the concepts like missing values, it takes a little bit of time, so to speak. Some of it needs to be watched twice. Because, well, I remember back myself when I was learning R, some concept you have to practice and you need to watch the video more than once, trust me, that's how it works, all right? But hope, Elena, I hope I answered the question about the null values, because this is an excellent question. I like the question. So, guys, excellent questions. So I'll make sure that the instructor knows that we had excellent questions tonight. Okay. So yes, go ahead, type questions if you have more of them. Okay. So, and I hope I addressed them as best as I could. Okay. Well, if there are no more questions, then I'm going to end the recording. I'm going to end the recording now. And okay, most welcome. And I want to thank everyone for being here. Okay. And hope, okay, have a nice semester.